Hello everyone, welcome to Trigonometric Identities. This unit is a favorite among math teachers. It is really an incredible unit because we like a challenge, and this unit is challenging. A trigonometric identity is like a puzzle in which you have to be crafty, knowledgeable, you have to take risks, and willing to get a lot of things wrong before you get them right. Let us define a trigonometric identity. A trigonometric identity is a trigonometric equation that is true for all the values of an angle. Mark that up. Both sides of an equation must be equal for all theta. So we know already some trigonometric identities, and they're called the reciprocal and the quotient identities. So, for instance, cosecant x is equal to 1 over sine x for all angles x. Secant x is equal to 1 over cosine x for all x values. By definition, they are the same thing. Cotan x is equal to tangent x for all angles x. Now, quotient identities, we already seen these, and we may have not called them identities, but tan x is equal to sine x over cos x for all angles. Last but not least, cotan x. Cotan x is a reciprocal identity, but it also is a quotient identity in which cosine x over sine x is equal to cotan x, and this is true for all x. So we're just going to start off very simply. This is what we know. No news, keep moving on. So let's consider cosecant theta is equal to cotan theta over cosine. Is this true for all angles? I don't know. Actually, I do because I did some practice examples, but otherwise, I don't know. And the whole purpose of a trigonometric identity is to prove that it is true for all angles. So we're going to identify the non-permissible values. So I am just going to write the non-permissible values. So the left-hand side is 1 over sine. The right-hand side is cotan, which is really cosine theta over sine theta divided by cosine theta. So really my non-permissible values are, my denominators can't be equal to 0. So I'm not going to take too much time, but really my non-permissible values for theta are solving these inequalities where cotan theta can't be equal to 0 and sine theta can't be equal to 0. And those are fairly easy enough to get. Although it's not stated in radians or degrees, we could pick either one and there we would have it. All right, B. So wouldn't it make sense that if we're trying to prove something is true for all angles, that we actually test it out for one angle? So what we're going to do is we're going to test if the equation is true for theta is equal to pi over 6. So really I have cosecant of pi over 6, and I'm just going to substitute this in, is equal to the cotangent of pi over 6 divided by cosine of pi over 6. So the cosecant of pi over 6 is, I'm going to switch colors so I get myself a little bit more room here. 1 over sine of pi over 6 is equal to the cotangent. Now I like to think of it as 1 over tangent. That's the way I like to think about it. Divided by the cosine of pi over 6. Now hopefully I do this right. The sine of, or 1, I'm going to move it up here now and switch colors. 1 over the sine of pi over 6. Well, the sine of pi over 6 is 1/2. 1 over the tangent of pi over 6 is 1 over root 3. divided by the cosine of pi over 6 is root 3 over 2. Now, I'm just going to simplify this. The left-hand side is 2. The right-hand side, well, it's just a mess, isn't it? So I'm just going to choose to evaluate my numerator first, and then I'll worry about this denominator. So 1 divided by 1 over root 3 is root 3, divided by root 3 over 2. And what I get is 2 is equal to root 3, and I'm going to multiply by the reciprocal of the denominator. So I get 2 is equal to 2. So we have an equality here. So what did I just demonstrate? I haven't demonstrated that it is true for all theta, but I have demonstrated that it is true for this specific theta. I haven't proved that it's an identity yet, but therefore, I can say that cosecant theta is equal to cotangent theta divided by cosine theta only for theta is equal to pi over 6. And that's what I have proved. So I have proven it for one angle. And by the way, if you can think of an example where this identity or this candidate is not true, just one angle, then it is not an identity. It's not true for all angles. But regardless, let us start off with our identity. Our identity, when we prove trigonometric identities, we write them in certain ways. As math teachers, we write them with a sort of finesse that we like. And first things first, you need to write down your identity. Now, it sounds simple, but so many people don't do it. And then they copy something down incorrectly, and then they work on something for a very long time that's just incorrectly copied down. So really, what I do, can I tell you what's not allowed? You are not allowed to multiply both sides by a quantity. Take this down. In notes on the margin, really what you must do is you must treat it as two different expressions. The left-hand side and the right-hand side. They're almost like two questions. You need to simplify both equations independently, and hopefully you'll end up in the same place. If your algebraic manipulation has the same values at the end, then you can conclude that we have an identity. So I'm going to start off, and I'm going to call it the left-hand side. So the left-hand side is equal to cosecant theta. The right-hand side is equal to cotangent theta over cosine theta. So I'm going to maybe create a different column, my work here. And I'm going to work my left-hand side. Then I'm going to work my right-hand side. And I'm hoping that when I work, I'm going to start off cosecant theta, and the right-hand side is cotangent theta. Hopefully, after a whole bunch of work, I get the same expression at the bottom. So the left-hand side, cosecant theta, I would probably write it as 1 over sine theta. That is the simplest that I could do it. Generally speaking, it's always a good place to go to sine, cosine, and tangent, or maybe just sine and cosine. But you'll get the hang of this. A lot of trial and error. So the right-hand side is cotangent theta divided by cosine theta. So I'm going to write this as cotangent is cosine theta divided by sine of theta divided by cosine of theta. So now what I have is cosine of theta divided by sine of theta divided by cosine of theta, I'm just going to simply multiply by the reciprocal of my denominator. So cosine theta divided by sine of theta times 1 over cosine theta. I cross out common factors of cosine theta. All I'm left with is 1 over sine theta. And then I could say, now, what have I recognized? I'm going to put this in a box, and I can say right-hand side is equal to left-hand side. I know that bothers some of you because I wrote right-hand side first, but then I could say, therefore, cosecant theta is equal to cotangent theta over cosine theta. These two are actually the same quantities.